All right, so this study guide, the one that's right at the top of Schoology, the purple one, matches your Illuminate portion that you'll be taking. So this one's number 2 on it. Sam claims that the solution to this expression is 92. She wants to prove this claim using the 4 assumptions below. I'll reread those because I'm probably going to have to read a bunch. Sam chose the following steps to prove her claim that the solution to the equation is 92. I'm assuming is what she said before. And then it says match the number of the assumption used in each step of the proof. Okay, so we're matching these assumptions to the steps. So we have like terms can be added or subtracted. We have distributive property. We have addition property of equality and division property of equality. For these, like, and it's not saying she made a mistake anywhere, but for problems like this where you're evaluating the steps, you should probably see what they are doing to go from step 1 to step 2. Like literally see what is different. So here's my original. What is the difference going from my original given problem to the step right below it? What changed? I'm not saying you have to tell me what assumption it is. I'm telling you to tell me what is the difference from this one to this one. Literally what changed, what's not there anymore. Okay, this disappeared. What do they do here when it's set up like this to make it disappear? So they did the distributive property in step 1. That's what makes the parentheses go away. That's why it became 4x minus 20, because when you distribute, you take the outside number and multiply it by both of the inside terms, and they did that correctly. So that goes with assumption 2, the way that they labeled it. Now see what's happening when we go from step 1 to step 2. What changed? It became from 12x plus 4x to 16x. What's that called when they do that? Combine like terms. So that is which assumption that's listed? Assumption 1. So the like terms can be added, goes with assumption 1. Step 2 goes with assumption. All right, now see the difference from step 2 to step 3. What changed? The minus 20 is not there anymore. How do I make the minus 20 go away? Add 20. Did they do that on both sides? And they're supposed to, because that's how you keep it equal. So what do we call that when we add the same thing on both sides? Good, addition property of equality. Make sure that when you're reading these, you're seeing what they did to go from the previous step to the next one. And that goes with assumption 3. Okay, so then process of elimination. This one must be the division property, but does that make sense? Did they divide to go from 16x to just x? They did. So that means I divided 16 on each side. That's what got me to my step 4. And that goes with assumption 4. All right, so when I'm doing my matching, it's going to go 2, 1, 3, 4. So let me put that and make sure the key is right. I'm going to erase this. Going to go 2, 1, 3, 4. Now let me make sure the key is correct. And it is. So you should be able to match the step with the correct property. But if I'm remembering correctly, on your test, it's actually gonna have you find the error. So you have to be able to tell, is that the right property that goes with that step? Is that the right step to do? In this one, she didn't make a mistake. On your test, there will be one. You have to identify it. All right, questions on this one? Questions on others? Wait, number 9 on this one. Okay, so it says compare the rate of change and initial values. I can see why we might struggle with this one because we didn't necessarily use that verbiage, but we did, what it's asking you to compare, we did compare in the unit. So when I say rate of change, what am I talking about? What's another word for rate of change? Maybe look what they're giving you. Tables we didn't do a whole lot with, but graphs for sure. What's my rate of change of my graph called? Slope. So when they say compare rate of change, we're really saying compare the slope. And initial value is what part of the graph? When we talk about slope, this is usually paired with it. You usually plot it first. Your y-intercept. So whenever we're talking about initial value, because usually it's a real world situation, that's your y-intercept. Fine. This one really is only focusing on rate of change if you look at where you have to input stuff. But yeah, if you want to compare rate of change, we're talking about comparing the slope. If you want to compare the initial values, we're talking about comparing the y-intercepts. Let's start with from this graph first, because that you should recognize from this unit. How do you find rate of change or slope on a graph? What's the formula for it on a graph? So y equals mx plus b is not the same as slope. Y equals mx plus b is slope-intercept form, but slope is just the m. How do I find slope from a graph? Rise over run. Again, we're talking about just the m, not the whole y equals mx plus b. So slope is rise over run. For that, you need to find two parts of your graph. You need to find two parts of your graph that you can see really clearly without having to estimate. They already actually chose some for you. But know that I wouldn't pick like this right here because I'd have to estimate it. So you want to pick things you don't have to estimate. You could draw a triangle or visualize a triangle, if that helps. And you're counting your rides to get from this point to that point and your run. It's always like how you reach from left to right. So going from my left point to my right point, how much do I have to go up? Good, 4. If I had to go down, then it would be negative. Okay, but I'm not positive. And what's my run? It is 7. So make sure when you're counting, like here's, I guess, 0, you could say 1, 2, 3, 4, 5, 6, 7. So rise over run, and this is for function 2, is 4 over 7. I started with that one because this is more of what I'm seeing in the unit. Tables are still important though. So you can use Desmos, and then I'll show you another way too. You can plot coordinates in Desmos and then count the rise and run. So that first coordinate was 2, 0, I believe. You can type it like this, 2, 0 in parentheses. That's how you make the coordinate. See it here on my graph. And then the next coordinate is 9, 4. You only need 2. And you can see my 9, 4 coordinate over here. You can count your rides over your run, stop talking. But notice that these tick marks are going up by how many? Not 2. 0.5 actually. So you don't want to count each of these individual ones. You can zoom out. So that way it becomes counting by ones, and that's nicer. And we're going from this point to that point. How much do I have to go up? Good, 4 again. And how much do I have to go to the right? 7. So they have the same slope. So 4, 7. And then when it asks, are they greater, equal, or less than, you would put that they are equal. And literally just put in equal signs. That's what it said. But so that was how you can do it in Desmos. So it's like what you saw in the unit. I'm going to show you something else that I think is easier. When it's in table form, this formula is also rise over run, but it's just represented a little differently. It's change in Y over change in X. So like rise over run, essentially. Just pick 2 areas to look at. Don't mix it up. What is my change in Y going from 0 to 4? What is my change in X going from 2 to 9? That's my slope. So whatever's easier, I didn't show you that before, so that's why I showed you in Desmos, so that's kind of the same as what you already saw, but you can use that now that you see. Questions on that? Yes, we do have Desmos on every unit test. You just don't have it on your state testing. So that's why if you want to do well on your state testing, you probably want to bring your own calculator and know how to use it. Go ahead. Other questions from any study guide? Steven? On this one? Okay, so what is the solution to the following equation? So when we say solution, we want to know the value of X that makes it true. There are some steps for like multi-step equations, if you will. Anyone know what the first step in this one would be? Good. You should always check if you can distribute. So that's why the first step is always like distribute if necessary. There will be times where you don't have to. Your computer lagging a ton. But if you see that you can distribute, you should do that first. Do I need to distribute in this one? Yeah, I'm actually distributing a fraction here. I'm also distributing this 3 over here. So distributing means take the outside number, multiply it by both terms inside. Class, what do we get from distributing this 3? Okay, good. People always forget to multiply it by the second term. Got to multiply it by both. And remember, you keep the sign that's in front of each term. So I'm multiplying a negative 1/2 on this one. So what's negative 1/2 times 4? Negative 2x. And what's negative 1/2 times 6? Just negative 3. But side note, hopefully you guys know how to use your calculator. There will be fractions on your test. All you had to do with this one was do this. Negative 1/2 times 6. That is negative 3. And then when it was times the 4x, I mean, the calculator won't do that for you. It won't do the x for you, but it can do the number 3. and then you need to remember to put the x there. Okay, so that's me distributing. I'm gonna write down, just basically bringing this down. All I did was distribute. Any questions on that so far? Usually after distributing, you have to do this. What is it? Combine like terms. So on my left side of my equal sign C, are there any terms I can combine with the 3x? When I combine them, what is 3x minus 2x? A positive 1x. And then, do I have any like terms that I can combine with this 6? The negative 3. Combine means add, so people always ask me, is it 6 plus negative 3 or 6 minus 3? That's literally the same. 6 plus a negative 3 is the same as 6 minus 3. So just keep the sign that's in front of each term and then combine it. So what's 6 minus 3? And it's positive, so I'm going to put plus 3. And now it's really easy. Usually, if there are variables on both sides, which there's not, so you don't have to worry about it this time. But this step should usually be in your list of steps if you're memorizing things. Move variable to one side if necessary. This step is also if necessary. You won't always have to combine like terms. But then the very last step is just to isolate x. And that might be like a 2-step equation. And this one, it's a 1-step. How do I get rid of that plus 3? And whatever you do to one side. So what does x equal in this one? A positive 31. It already has x equals, so you should just be typing 31 in there. Good, any questions? And you can show answers to be sure, and it is 31. All right, might have time for one more depending on how long it is. Any other requests? Amy? Question 6. So I think my first hour asked completely different questions. So if you want to see what they asked, and maybe you went into trouble later, you could look at that video. But again, if you don't ask before tomorrow, then you will struggle with that same question tomorrow. The study guides are closely aligned to the real test. Now, number 6 on this study guide is like what we learned yesterday, how to make the system and solve it. So if you read it, you know it's a system because you should see 2 totals. That's a good place to start if you are struggling making your system of equations. Class, what are my 2 totals in this situation? All right, a little louder. So that's not a total. 6.25 is what he spent total, so that's what I mean by total. And then 11 is what he bought, like 11 total pens and pencils. That's how you can make your system. These other numbers are kind of like supporting details. Like these contribute to the dollar amount he spent, right? So you have to use that to make your equation, and it should be paired with this total because it's a dollar amount. Class, what's the equation going to be on this side? X plus y equals 6.25. That will give me the breakdown of what he spent. If I have a dollar amount as my total, on the other side should be something with dollar amount. Sometimes what we're trying to solve for is a dollar amount, but it's not this time. Okay, great, this is better now. These need to be in front of it to give me the cost. For the total that they bought, so like evaluate what your variables are. X represents what? It's the number of pens bought. Because the pens cost 75 cents. The Y is what? Or of pencils bought. So knowing that, and knowing that this total is how many they bought combined, what does this equation have to be? Just X plus Y for that. Because literally, I don't have to multiply it by anything, I'm just counting how many pens I bought, how many pencils I bought, and adding. Now this, because it doesn't say, it only wants your final answer. It doesn't say do it a certain way. What's probably the fastest and most accurate way to solve this? So that's what I'm gonna do. I'm gonna type it in Desmos and see where they intersect. So 0.75x plus 0.25y equals 6.25. Oh, whatever, it's your grade, it's not my grade. Anyway, I graphed it. I need to see where it intersects. And then go back and read what X was. X was the number of pens bought. I bought 7 pens. Y was your number of pencils bought. For pencils. Questions, comments, concerns? Okay. Well, test tomorrow. If you have more questions, you can email me. I try to help you.